Good evening, students. Well, okay. So I had a query yesterday, and they were asking about a question in kinematics, some of my students. So I thought maybe let us take up that particular query and then start working on it. Okay, so welcome to Misconceptions in Physics, Solving Problems. My name is Ratankar Rao. I teach physics in an international school, and it is my passion of collecting problems which are quite harder for students and they make mistakes. I just look at those mistakes and try to resolve them. Okay, now this is about me. I'm sorry, I have just loaded the same slide. Okay, let me go back. And if you want to look at all my videos, then you can visit to my website, which is at ratankar.com in my name. So there are several videos present there, and you can also know more about me and what are my interests. Now let me proceed to my video. So the problem that is being posted here is like this, which tells you a ball is being dropped from a balloon going at a speed of 7 meters per second. So you have a balloon. You have a balloon. Now this balloon is going at a speed of 7 meters per second. Okay. And a ball is being dropped from here. You drop a ball here. The balloon was at a height of 60 meters from the ground. Balloon is, I'm sorry, this is my ground. I don't know why my pen is not writing properly. This is my height. How much is this? 60 meters. Okay. Now, how long will the ball take in reaching the ground? That's the question. So towards it, what the student has done is, they have thought that anyway the ball is being dropped over here. So the initial velocity of the ball they have taken is 7 meters per second. Okay. And then S is equal to 60 meters, the height 60 meters. And then T is equal to what? So directly they have used S equal to UT plus half AT squared. Okay, this is one type of solution that I have got. And some of them, what they have done is, they have taken this phrase, dropping. Okay, so dropping, what does dropping means? Dropping means the initial velocity equal to 0. And as a result of it, see, this is the first method I have got. First method is, they have assumed dropping. Dropping means u equal to 0, initial velocity is equal to 0. And use the equation S equal to ut plus half at square. They have substituted a equal to g. Okay, they said that S is minus S, and this is 0 plus half, and a is minus g, and this is t square. And thus I can find out what's the value of t, which should be equal to 2s by a. Okay, this is the 2s by g. This is the method that I have employed. Now, why is this correct or why is this incorrect? Not correct. Why is this incorrect? The reason behind this, when you drop a particle from here, now what happens to the velocity of the particle? The velocity of this ball is nothing but the same as the velocity of the balloon, which means this velocity is also 7 meters per second. 7 meters per second. Now, if that is the case, the balloon and this one should go uniformly, right? Why is it not going uniformly? Because this is going with uniform velocity. Balloon is going with uniform velocity. While this ball, okay, it has a velocity 7 meters per second, but there is a culprit here. Who is that? Gravity. Okay. This gravity is now trying to pull the ball. Now, as it tries to pull the ball, the velocity of this ball now reduces from 7 meters per second to 6 meters per second, 5 meters per second, 4, 3, 2, 1, and finally 0. Which means what will happen to the ball? The ball will now start moving slower and slower, and finally it will reach this point, maximum height, and then it will start coming down, right? The ball does not directly come down. The moment you put over here, it will not drop it down here, but it will take a trajectory like this path. Okay, this someone has to understand it. So you cannot have u equal to 0. If you say u equal to 0, which means You drop the ball here, the ball starts coming directly. Okay, it doesn't take this path. So this will happen when the balloon is not open. Now is not moving. Is not moving. Is not moving. Okay. Now let us look at the second method. So this method is incorrect. Let us look at second method our student had, which I have written it here. They have taken this into consideration. Okay, this is something like which have not understood the problem at all. Second method, they have understood the problem, but they have got a confusion. Now, what is the confusion? The confusion here is that when you throw a ball, it moves with a velocity 7 meters per second. They have taken this as your origin and this as your vertical y-axis. They have taken this value. And then S is equal to 760 meters. Displacement is 60 meters. They have taken this height. Now here they have got confused with distance and displacement. Why do I say so? Because you see, if this is my origin, anything that goes upwards is positive and anything that comes downwards is negative. And in your equation, S is nothing but displacement, not distance. Which means what you should have? You should take the distance starting from this point to this point. Which means now the displacement is negative over here. But what did they consider? They considered S to be positive and thereby they substituted these values. And finally, they got an answer which is seen to be imaginary in nature. And immediately, my student said, sir, you have given me a problem, okay, which is having incorrect values. So this cannot have. Time cannot be imaginary. And some students, they thought, hey, whatever is given doesn't matter. Put a plus sign here and get the value. Okay. So this is incorrect. Now, let us look at what could be the correct solution. Now, let me restart from the beginning. So I said the ball is going up with the speed of 7 meters per second. You are right. The value of U is correctly given here. The ball was at a height of 60 meters. The value of S. Okay. Now you see, this is the balloon. The ball is dropped from here. The ball goes all the way along and comes back like this. Now, what is the displacement? Displacement, you have to take this as your origin, the balloon as the origin. This as my x-axis, this is my y-axis. And the ball comes down. So therefore, the value of S is equal to minus 60 meters. Okay. And then how long will the ball take in reaching the ground? Now, this is what has been asked. What's the value of U? U is given. Now, we need to find out the value of time. So, let us use S equal to ut plus half at square. Let us substitute the value of all these parameters. This should be minus 60. This should be equal to U. What is U? 7t. And then plus half into what is here? Minus g. Right? Why minus g? Because gravity is pulling it downwards, right? Gravity is a vector, okay, which is negative vector. Minus t into t square. Okay. So towards it, let us solve this. So this should be 70 minus 5t square. If I transpose it back, I can now write this as 5t square minus 70 minus 60 should be equal to 0. So this implies t should be equal to 7 plus or minus square root of b square 49 minus 4 into a. What is a? 5 into minus 60. Into minus 60 divided by 10. Which should now be equal to. Let's compute this value. So what do I get? 7 plus or minus square root of, this is 49. Then minus 4 into minus 5 is minus 20. Minus 20 into minus 60 should be plus 1200 divided by 10. This should now be equal to 7 plus or minus square root of 1249 divided by 10. Right? So let me find out using my calculator what is this value. This value would now be square root of, I'm sorry, just a moment. Square root of 1249. Then should I take plus sign or minus sign? It should be only plus sign. So you will get the answer as 4.23 seconds. 4.23 seconds. Does the ball will take 4.23 seconds To start from here, go to the maximum and once again come back to the ground. It takes such a long time. I hope you have understood this video clearly. So if you have any such doubts, you can always write back to me. The whole set of videos that has been recorded so far, which has been put forward so far for the past 3 months, is everything is being available in my channel, and as well in my website. So you can use any one of them, okay, to understand it clearly. Thank you, friends, for watching this. If you like my videos, do share and subscribe to my channel for more updates. Thank you.